Hi, this is Dorothy Wiggin, and today I am going to be speaking about the immune system and different things about it. And yeah, first we're going to talk about the innate and adaptive immunity. So innate immunity is the first line of defense. It's the immediate response of the immune system, and it has a protection. It gives you a protection over a wide range of pathogens. It's not like specific to any kind of pathogens. It's really fast. You're born with it. You get it since birth. And yeah, so it's not like specific to any specific disease or pathogen. And then the adaptive immunity response is it's a lot slower. It can take days to weeks to develop. It's specific to pathogens. It kind of like develops over time. It can take weeks or days or weeks to develop, and it's specific once the pathogen or virus once it gets used to it, it has a memory. So it like keeps the memory. So if it comes in contact with the system, comes in contact with it again, it stays in the memory of the immune system, and it'll at that point fight it. And it's specific, it's sophisticated. Yeah. Also, yeah, it's highly specific to pathogens and recognizes ones from the past. Next, we're going to talk about what are we talking about? Examples of passive natural and artificial, and active natural and artificial immunities. So natural passive examples would be like maternal antibodies from your mother. You can get them from the placenta or breast milk. It has immediate protection. It's not like developed over time. You have it as when you're an infant in your early life. And then artificial, where are we? Yeah, the passive artificial would be like a immune serum, like kind of like anti-venom, an injection of antibodies from a serum of someone that already had the immunity. So like anti-venom. And then then let's talk about active ones. So active natural is would be like when your own system fights an infection, so your recovery from an infection due to an immune system response. And then your body remembers it since it already fought it off before, so it results in the development of a specific and immune memory. And then the active artificial example immunity would be like vaccination, which induces a specific immune response, and it also includes antibodies, memory cells, because your body takes the vaccine and yeah, it provides protection for future exposure. Now we're gonna go over the thymus and the pharyngeal tonsils. So let me pull that up here. So let's do thymus first. So there's the thymus right here. It's located in the mediastinum. This is the mediastinum. It's posterior to the breastbone, inferior to the heart, anterior to the heart, inferior, anterior to the heart, in the mediastinum, right in between the lungs. It's a small gland. It makes and trains special white blood cells called T cells. And it produces most of your T cells when you're a baby, when you're really young, like at birth. As we age, it shrinks. when you're born, it's like super big in your chest, and then as we age, it shrinks, and then it's like covered by fat. And it doesn't like produce any more T cells after a while. And it becomes less active. It does remain essential in early immune system development and maintaining immune function. It's pretty much just like a gland that it's a part of the lymphatic system, and it protects our immune system. So yeah, it's in the medial sternum, posterior of the breastbone, inferior anterior to the heart. Okay, it's the initial site of the T cell maturation. It helps the T cells mature, which T cells are cells that protect our immune system, that are part of our immune system, that protect us from pathogens. It has 2 lobes. Anywho, let's talk about the pharynx. So the pharynx is, the pharyngeal tonsils. So the pharyngeal tonsils are right here, right behind like the nasal cavity, right there. Am I pointing that right? Right here. Oh, and if I missed the thymus, it was right there. Okay, so yeah. I don't know if I was pointing the camera right at my screen earlier. I just realized that I wasn't doing that right now. So anywho, so here's the pharyngeal tonsils. So they are in this is the nasopharynx, and that's where they sit. They are part of the lymphatic system, and they increase the capability of the lymphatic system against foreign organisms and pathogens. They are most active when we are young. So pathogens that come in through the nose and mouth, that's like one of the first lines of defense, especially for younger kids. They do shrink as well when we around 5 years old. They start to shrink around 5 years old, and then they almost disappear by our teenage years. They grow while the kid is young. So yeah, they're in the roof of the mouth, back of the posterior to the nasal cavity. Roof of the nasal pharynx, nose and throat area. Okay, and then the last thing we're going to discuss is HIV. I'm going over time, sorry. So HIV is the human immunodeficiency virus. It primarily targets the immune system. So I'm a conspiracy theorist, so you don't want to get me started on that. But it targets the immune system, specifically the CD4 cells and the T cells, also the macrophages and the dendritic cells. As it replicates itself, it damages and eventually destroys the infected CD4 cells and T cells. It's progressive over time. Over time, it does turn into the AIDS virus, which is the acquired immunodeficiency syndrome. Yeah, not the AIDS virus, acquired immunodeficiency syndrome. That's when your immune system is severely compromised. And the way that we know that it's not just HIV and it's AIDS is that you have a significant drop in your CD4 and your T cells. So the virus basically binds to the CD4 receptors on the surface of the co-receptors, and it compromises the body's ability to defend itself against infections and diseases. So it's like deadly. It's like your body just basically doesn't have the ability to fight off like pathogens and viruses, bacteria, anything that comes in. Like your system is just messed up and you can't fight it. So that's why it's so bad. Like it literally takes over your cells, kills them, and then the cells that come in later that are replicated are jacked up already because it's in the cells. It like binds to the RNA, to DNA. Yeah, it's a hot mess. So yeah, viral DNA integrates into the host cell's genome, becoming a permanent part of the infected cell. Yeah. So yeah, as it continuously does this, it just weakens the whole immune system and ability to fight off infections and leads to acquired immunodeficiency syndrome, which is AIDS. That's really terrible, but going over time, so that will be it. Yeah, thank you.